Hi, my name is Mel, and this presentation will explore the fascinating world of computer keyboards, covering their history, various types, key components, and latest innovations. We will dive into layout designs, switch mechanisms, specialty keyboards, connectivity options, and future trends shaping how we interact with computers. We will begin with an introduction to computer keyboards and their evolution. Then we will explore the components and operation, followed by different keyboard layouts and switch technologies. We will also cover specialty keyboards, key features, connectivity, and conclude with future trends and innovations. The following section provides an overview of keyboards, tracing their history, significance in computing, and fundamental functions to enable user interaction with computers. Keyboards have evolved from typewriters to electronic input devices. Early designs influenced modern layouts, enhancing usability and speed for computer users worldwide. And this is probably, they had the QWERTY pattern on keyboards so that typewriters couldn't type too far and jam up the typewriter, and that's why most keyboards are the QWERTY type, just so you know that. Keyboards remain a primary input device essential for typing, shortcuts, and commands, bridging human-computer communication effectively and efficiently. Keyboards allow users to input characters, navigate interfaces, and execute commands, supporting diverse computing tasks from casual use to professional applications. Understanding the internal and external components of a keyboard helps explain how they detect keystrokes and communicate with computers. Keyboards consist of keys mounted on switches connected to electronic circuitry that detects and translates key presses into signals. Once a key is pressed, the keyboard circuitry processes the input and sends data to the computer, either through wired or wireless connections. Wired keyboards connect via USB or PS/2 port, providing stable signals, while wireless keyboards offer mobility using Bluetooth or proprietary dongles. Keyboards layouts dictate key arrangement and vary globally to accommodate different languages and typing efficiencies. The QWERTY layout was designed to prevent typewriter jams and remains the most widely used keyboard layout worldwide. AZERTY is common in France, while Dvorak and Colmac layouts aim to increase typing efficiency and reduce finger movement compared to QWERTY. Okay, so there you go. Various layouts are tailored to specific languages and regional characteristics, enhancing typing, comfort, and accuracy for local users. Mechanical keyboards use individual mechanical switches beneath keys, offering tactile feedback and durability favored by enthusiasts and professionals. Mechanical switches register keystroke through physical movement and electrical contacts, providing distinct feedback and sound profiles. And a lot of people like feeling the keyboard because if you don't feel it go down, you don't think it's been pressed. Cherry, MX, Roma G and other switch types differ in actuation force, travel distance and noise, catering to different user preferences. And yeah, that is all just a user preference, like how hard do you need to press it, like how far does it need to go, and how much noise does it make, okay? Mechanical keyboards offer precision and longevity, but tend to be heavier and more expensive than other types, which may impact portability and cost. These keyboards use pressure pads and rubber domes for input, generally resulting in quieter, more affordable options suitable for everyday use. So membrane and dome switch keyboards is what we're talking about now. Membrane keyboards have layers of flexible material with conductive traces that close circuits when keys are pressed. Dome switches use rubber domes beneath keys to provide tactile feedback by collapsing when pressed, completing the circuit. Membrane and dome switch keyboards are cost-effective and common in offices, though they may lack the tactile responsiveness of mechanical alternatives. Yeah, they usually are more cost-effective, but depends where you go. Scissor switch and other mechanisms offer a balance of stability and low-profile design, popular laptops and slim keyboards. Scissor switch keyboards use interlocking plastic pieces between or beneath keys to stabilize them and provide a shorter travel distance and quieter typing experience. Butterfly switches are ultra-thin mechanisms designed for slim laptops, although some models have faced durability concerns. Each switch mechanism offers distinct typing feel and longevity, influencing user preference and keyboard lifespan. Specialty keyboards enhance ergonomics, portability, or customization for specific user needs, from gaming to accessibility. Like a braille keyboard, or like ergonomic keyboards are common too for people with RSI, repetitive strain injury. Ergonomic keyboards are designed to reduce strain by promoting natural hand and wrist positions, improving comfort and during extended use. Split keyboards separate key groups for better posture, while compact keyboards reduce size by removing less used keys, aiding portability. Programmable keyboards allow key remapping and macros favoured by gamers and power users for enhanced control and efficiency. Modern keyboards include features such as customizable lighting, key rollover, and replaceable keycaps to meet varied user preferences. Backlighting improves visibility in low light, while RGB lighting offers customizable colors and effects for personalization and aesthetics. Key rollover allows multiple simultaneously key presses to register accurately, and anti-ghosting prevents phantom inputs, crucial for gaming and fast typing. Keycaps vary in materials like ABS or PBT, affecting texture and durability. Users can customize keycaps to enhance feel and appearance. Connectivity options and compatibility affect ease of use across device and operating systems, influencing user experience. Keyboards are connected via USB cables, Bluetooth, or proprietary wireless dongles, each offering benefits in latency, range, and convenience. Most keyboards support major operating systems, but some features or shortcuts may vary, so compatibility is important when choosing a keyboard. Look, it's only if you're doing pretty specific things you'd need to worry about that, but yeah, mostly you wouldn't. Hot swappable keyboards allow users to change switches without soldering, and firmware updates can improve functionality and add features. Yeah. So that can be something that's good too. Emerging technologies are shaping the future of keyboards, making input more adaptive, sustainable, and integrated with digital environments. Touchscreen and virtual keyboards offer flexible, software-based input methods, enabling dynamic layouts and integration with various devices. Yeah, that can be good too. They project a keyboard out into like a desktop, and it uses laser and light rays to detect where your hands press on, and you'll have a keyboard and it detects which key your hand's pressed, and that's how it does it. It can be quite good. Haptic feedback provides tactile sensations to virtual keys, while adaptive technology can modify layouts or functions based on user behaviour or context. Innovations focus on eco-friendly materials and sustainable manufacturing processes to reduce environmental impact of keyboard production. Look, if keyboards stuff up, generally it is cheaper and more time efficient just to replace them. But this is where I'm saying we should have electronic waste bins where electronics that no longer work can go in and be the materials that are used can be recycled. Okay, because I think that would be a really good idea that we do. Computer keyboards continue to evolve with diverse types, features and technologies, enhancing user interaction, understanding their components and innovations to help user select the best keyboards to meet their needs while hopefully anticipating future advancements. Thank you for your time.